Hi, we're talking about fixed length subnet mask today, which is another uh, which is another method to actually create smaller subnet group with a big subnet group. You can see that for today's scenario, we are given a IP address, network address 10.16.32.0/23, which is a big subnet group to be used in order for us to split it into smaller subnet to accommodate the different departments that you can see in the scenario today, which I will have management department with 3 IP requirement, human resource with 13 IP requirement, finance 28, transport 60, and sales 48. For those who have actually gone through the training on variable length subnet mask FLSM, you should know that the reason why we need to actually create smaller subnet group from a bigger subnet is actually to make our more efficient usage of our IP addresses, especially for IPv4. Address is basically a constraint. And even as we are talking now, IPv4 address has already run out. That is the reason why we have IPv6. So if we were to do some calculation based on this bigger group subnet, with a /23 subnet mask, we will know that IPv4 address basically is a 32-bit number. So 32 minus 23, basically I'll be getting 9 host bit. So basically 2 to the power of 9, 9 host bit will give me 512. It will mean that for this network address 10.16.32.0 with the subnet mask of /23, I will be having a very big group of IP addresses, 512. And basically it definitely, because it's just one group, I won't be able to split. I won't be able to use it for 5 different groups. If I want to have separate subnet for every individual group. That basically brings us to what we're going to do today, is splitting up this /23 into smaller groups. But before we go on, in order to actually do the variable length subnet mask, let's just look at the conversion from the decimal dotted notation form to its binary form, so that later when we are working with the different calculation, it's much more easier to work with. So basically a /23 subnet mask will be 255.255.255 .254.0. So basically if we were to convert it to its binary equivalent, it will be 0 0 0 0 1 0 1 0 0. Because 8 plus 2 will give me 10. The second octave much more simpler, only 16. The octave also very simple, is 32. And the last octave is basically all 0. When we convert it to its binary equivalent. So when we're given a subnet mask in its prefix form, /23 basically means that I will have 23 bits of 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Followed by 9 bits of host. Basically all the 1 is our network bit, and all the 0 is our host bit. That's the reason why we use 2 to the power 9 to calculate the host bit. So basically, why is fixed length subnet mask being used, especially in the industry? Because for certifications such as CSNA, even for tests, normally question will revolve around FLSM, because we're talking about the most efficient usage of the IP addresses. But in a typical industry network, we won't want to have different subnet masks for different departments or different rooms or different offices within the same company. Because it will be very tedious and challenging for an engineer to actually try to manage so many different types of subnet when I go from room to room. So normally in the industry, we'll actually be looking at fixed line subnet masks, whereby the subnet masks used are more consistent with all the different offices or room. So basically this brings us to look at how we're going to calculate okay, the subnet mask to be used given a big subnet mask, and what are all the network address, okay, that is being used for all the different subnet. Okay, so basically if we look at here, okay, the first thing in order to work with fixed line subnet mask is actually to calculate how many subnet are you going to create from the original bigger subnet group. So we can see that we have 5 different departments. Okay, basically means that I need to have at least 5 different subnet. Okay, and how to create at least 5 different subnet? Okay, we will actually need to look at the subnet mask and to play around by borrowing the host bit. Okay, so if we were to borrow 1 bit from the host bit, okay, which basically means that instead of /23, you can see from the Excel sheet, okay, I change it to /24. Okay, so by increasing 1 bit, okay, basically it will means that I will have 2 to the power of 1, okay, subnet, which basically will give me 2 subnet. Okay, and since I need 5, 2 subnet is not enough. Okay, so the next choice is to increase by using 1 more bit. That means that instead of, okay, borrowing 1 bit, I'm going to borrow 2 bit. Okay, so by borrowing 2 bit, okay, the calculation is actually still the same. Okay, so instead of 23, I'm going to increase to /25, which is to increase by 2 bits. Okay, and now instead of 2 to the power of 1, it will be 2 to the power of 2. I'll be having 4 subnet. Okay, which is still not enough to accommodate my 5 subnet. Okay, so it means that I will actually need to now, okay, borrow 1 more bit. That means that instead of 2 bit, I will actually need to increase to 3 bit. Okay, so same thing again here. Okay, so instead of 23, I'm going to 25, I'm going to increase to 26, which is to increase 3 bit. Okay, and now it's to the power of 3, which will give me 8 subnet. Okay, so definitely 8 subnet is able to accommodate my 5 subnet. So instead of a /23, okay, the bigger group, in order to have 8 different subnet, I'm going to split my /23 into 8 different smaller group of /26. Okay, subnet mask. Okay, so basically after determine the number of bit to follow and with the new subnet mask to be used, okay, the new subnet mask to be used, okay, in order to calculate the network address, which is the first address of every subnet, okay, you're going to actually make use of the value that we use in the when we learn about how to convert between decimal to binary, binary to decimal. And since we are making use of the second bit of the 4th octave, okay, we basically have a value of 64. It will mean that for every group, okay, I will actually need to increase by 64, okay, to get to the next group network address. Okay, so by understanding this concept, okay, it will actually be very, very simple to actually learn. We know that the original address 10, okay, 10.16.32.16.32.0, okay, will be the first address originally for /23. So I'm going to change it to /26. So the network address for the first subnet, okay, will be actually 10.16.32.0/26. Okay, and basically, okay, by knowing the bit value, okay, that we actually use, okay, for that second bit of the 4th octave, which is 64, okay, it means that from 0, I will need to actually increase by 64. So from 0, okay, it will become 64, okay, and with the subnet mask /26. So basically, you just need to keep adding by 64 for all the different 8 subnet masks. Okay, this is second. Let me just write the other number series. 4th address, 5th, 6th, 7, Okay, and last but not least, okay, number 8. Okay, okay, so this will be my number 8. Okay, so okay, so 64 plus 64. Okay, the third subnet network address will be 128. The fourth subnet mask, okay, plus another 64 will be 192. Okay, and okay, 192 plus 64, okay, is actually 256. But we know that every octave, the maximum decimal value can only be 255. Okay, so in a way, it's like our normal decimal number when, okay, let's say I count from 1 to 9. When I reaches 9, okay, the 9 becomes 0 and then add a 1 in front. So it's like, okay, when I reaches the last number 255 here, if I need the next number, okay, I will actually go back to 0, and the third octave, I will increase it by 1. Okay, so the fifth subnet mask will actually be 33.0. Okay, and the sixth subnet mask, since I already started with 0, okay, the second octave is 64, third octave will be 128, and the last octave, which is the 8th subnet mask, subnet network address, will be 192. Okay, so basically this will be the new 8 smaller subnet that I can derive, okay, from the previous /23. Okay, and basically the network address will be the first address of every group. Okay, and from this, how do we get the broadcast address before we can get our first usable address to the last usable address, which is the usable address range? Okay, it's basically by making use of the next subnet network address. Okay, if we minus 1, okay, it will actually becomes, okay, the previous subnet broadcast address. Okay, so basically by minus 1, okay, 64 minus 1 will be 63. Okay, so it means that for the first subnet, the network address, okay, will be 110.16.32.0, and the broadcast address, okay, will be 10.16.32.63. And by knowing this, we will know that my usable IP address will be from 1 to 62. Okay, because network address plus 1, broadcast address minus 1. Okay, so this will be how we actually derive, okay, of the usable address range, the network address, and the broadcast address range. More or less is quite similar to what we have actually gone through previously, okay, in, okay, the other subnetting video. Okay, so basically you just need to actually keep repeating this step for all the other group. Okay, for all the other group. So for the second subnet broadcast address, I will need to make use of the third subnet network address. 128 minus 1 will be 127. So 64 plus 1 will be 65. 127 minus 1 will be 126. Okay, will be my usable IP address range for the second subnet group. Okay, and so basically you just need to keep repeating this procedure for the third subnet. Okay, will be 192 minus 1, so it becomes 191. So usable will be 129 to 190. Okay, and basically you just keep repeating this step for the fourth, for the fifth, okay, for the sixth subnet, for the seventh subnet, and last one is for the eighth. Okay, so okay, let's go to the fourth one. So for the fourth subnet group, okay, 10, 16, okay, so it's 33.0. Okay, so basically 33.0, the previous number will be 32.255. Okay, which just now I explained that. Okay, for example, 32.256, we cannot have that number. We actually go on to the next number, which is 33.0. Okay, so the usable number will be 193 all the way to 254. Okay, and then for the fifth, subnet broadcast address, okay, will be 33.63. Okay, because we need to get the number 6 subnet minus 1, 64 minus 1 will be 63. Okay, and the usable range, okay, will be actually 1 all the way to 62. Okay, but take note of the third octave, okay, which, okay, the IP address has changed. Okay, so basically we, as mentioned earlier, okay, we just need to actually continue, okay, with using the next subnet group, okay, to get the broadcast address for every different group. So this 65 to 126. Okay, for the 7 subnet broadcast will be from K33, okay, dot 191, okay, so the address will be from 129 to 190. Okay, the third octave is 33, just remember it. Okay, and for the 8, okay, it will be 33, okay, 33, okay, dot 255, which is actually the last address of the group. Okay, and the usable address will be 193 all the way to 254. Okay, and basically this will be all the different, this will be the 8 smaller subnet group with its network address, broadcast address, usable IP range, okay, which is given. Okay, so just to, okay, just to actually increase the understanding of how, okay, the subnet mask, how all these subnet masks has been determined and used. Okay, I'm going to actually do another example. Okay, so let's say, for example, now instead of, okay, creating 5 different departments, okay, let's say we're going to use the same address again, okay, with, okay, it's subnet mask /23, but instead of, let's say, 5 different departments, now I need it to be split into 3 different departments. Okay, so basically similar to what we have gone through just now, by borrowing the bit, okay, okay, we know that, okay, by borrowing a bit, also, sorry, let me just change the color. Okay, if we borrow 1 bit, will be 2 to the power 1, only 2 subnet, not enough. If 2 to the power 2 is 4 subnet, okay, you will actually be able to accommodate my 4 different subnet. Okay, so if I borrow 1 bit, okay, is 2 to the power of 1, so I'll be getting 2 subnet, okay, which basically not enough, okay, for my 3 department. So if I borrow 2 bit, okay, it will be 2 to the power of 2 will be equals to 4 subnet. Okay, so it will be enough for my 3 departments that I mentioned, okay, in this second example. Okay, so similar to how we need to know, okay, similar to how, what are the values to actually add on to create or to get the network address for the different group. Okay, previously when I have 3 bits, okay, I stop at the at the bit whereby I have a value of 64. But now because my increment of bit stop at the bit whereby I need to have a value of 128. So it means that, okay, in order to get the network address, I will actually need to increase it by 128 every time. So similar to what I've done earlier, okay, the first address, okay, will actually be the same network address that is given, but instead of /26, okay, now I'm actually using a /25 subnet mask. 4 plus 4 plus 4, 24, and another one bit is 25. So this will be the new subnet mask I need to use in order to create 4 smaller subnet from a /23 subnet group. Okay, so from here I will know that, okay, my second subnet, okay, my second, third and fourth, which is four group only, third, and last but not least the fourth. Okay, so basically 32.0 I need to add 128. So the second subnet network address okay, will be 10.16.32.128. And when I add, okay, 128 to 128 again, we're getting 256. So similar, okay, that I explained earlier, I don't have 256, I can only stop at 255. It means that since I reach 256, it means that it will be the next number. I will increase the top octave to 33 and okay, change this back to 0. Okay, and the last octave will basically be 33.128 after I add 128. So this will be the network address, okay, for all the 4 different subnet group, okay, and it will be the first address of the group. So similar to how I actually calculate the broadcast address, the first subnet broadcast address, okay, will be 10.16.32.127/25. Okay, this will be my first subnet mask broadcast address. Okay, and the second subnet broadcast address will be 10.16.32.255 because 33.0 minus 1 we will go back to the previous value. Okay, and the third subnet, 128 minus 1 will be 127. But take note that the third octet. So the third subnet broadcast address, will actually be using the fourth subnet network address 10.16.33.128 minus 1, which will give me 10.16.33.127. Okay, and last but not least, the fourth subnet broadcast address, will basically be 10.16.33.255. Okay, so by making use of the method which I think if you go and Google for it or on Cisco training curriculum, by making use of the value for that specific bit placing, this value that you add on to every network address to get the next subnet network address, these are also called the magic number method. Okay, and basically this is how you can make use of the magic number method to actually derive the different network address and broadcast address. In this case, making use of feed and subnet mask, it means that every group, every subnet have the same subnet mask.